Solutions. This is not a new term to you. What is a solution? Don't tell me it's answer to a problem. I'm talking about solutions in chemistry.
Hello, this is Dr. Vani and welcome to E3 STEM Academy.
What is a solution? When two things seamlessly combine, right? A solution is nothing but a mixture. It's a mixture of solute and solvent. So I used two terms here. I used a term solute and another term solvent. So solution is solute plus solvent. What is a solute and what is a solvent? Let's take a simple example of sugar solution. You all know sugar solution, right? How do we make a solution of sugar? You simply add sugar to water and you nicely mix it. So here you have two substances. You're taking sugar, you're adding it to a glass of water, right? So I have a glass of water and to that water, I'm adding sugar. So I have sugar. These are granules of sugar that I'm adding. And you take a spoon and you stir it. What is that doing? What's the purpose of stirring a solution? What does that do? When you take a spoon and you stir it, what does that do? What it does is it speeds up the process of dissolving the solute in the solvent. So here, sugar is my solute and water is my solvent. So the substance that is getting dissolved is your solute. Okay, so what's a solute? Solute is the substance that is getting dissolved. In this example, sugar is getting dissolved in water, and therefore sugar is the solute. The substance into which the solute is getting dissolved is called a solvent. So water here is a solvent because sugar is getting dissolved in water, right? So a solvent is the substance into which the solute is dissolved. That's the main difference between a solute and a solvent. Now, you might have seen different mixtures, right? You probably would have seen a mixture of like cereal with so many ingredients in it, right? If you take a bowl of cereal, it might have different ingredients in it. And you also have another mixture, which is sugar solution. What is the difference between these two mixtures? It's the process of separation of the ingredients, right? You can see in a bowl of trial mix, like so, if I take a bowl of trial mix, you can actually handpick them. You can separate them out. You can separate out all the circles. You can separate out all the stars. Whereas if you take a beaker or a glass of sugar solution, right? You cannot really separate out the solute and the solvent through a physical means like handpicking. You can still separate them out, right? How can you separate out a solution of sugar? The ingredients in a sugar solution or sugar and water. So I want to take out sugar from water. I cannot hand pick sugar. I cannot take out sugar from the solution by hand picking. But there is a method to separate them, right? Evaporate the water. So you can take this beaker of water, place it on the stove, and you allow the water to evaporate. You can see that there is deposition of sugar at the bottom. So you can still separate the ingredients in a solution. It's just that you cannot separate it through a physical means like hand picking, and you cannot see the ingredients of a solution separately like you would see in case of a trail mix. In case of a trail mix, you can see each one of the ingredients in the mixture, but in a solution, you cannot see the solute and the solvent separately. The solute gets completely dissolved in the solvent, giving you a solution. So when you're talking about a solution is a homogeneous mixture. Now I'm going to use a word here. I've used a word here, right? It is a homogeneous mixture of solute and solvent. So this is an example of a homogeneous mixture. Whereas this right here is a heterogeneous mixture. This is a heterogeneous mixture in the sense you're able to actually see the ingredients in the mixture. All right, they're all different, but here everything is getting mixed. You only see it as one substance, and that is your sugar solution. But that doesn't mean that you cannot separate out the ingredients. You can still separate them out. You can still take out sugar from the solution of sugar, right? You can separate out by evaporating the water. You can still get the sugar back. Same with salt. You take a spoon of salt, dissolve it in water, you get the solution of salt water. Milk and water. It's a homogeneous mixture. So sugar solution, salt solution, milk, these are all homogeneous mixtures. That means you cannot see the ingredients separately. They mix completely, right? Now, if you take oil and water, let's say you take oil and water and mix them, do you get a homogeneous solution? No, right? You don't get a homogeneous solution there. It's going to be heterogeneous because you can clearly see a layer of oil and water, and you can simply pour it out. You can see oil and water separating out into two layers. So this is a heterogeneous mixture. You can actually pour the oil out and you can separate it out. But you cannot do that with a homogeneous mixture. Okay, I hope you got the difference between a homogeneous mixture and a heterogeneous mixture. A solution is a homogeneous mixture. And it is a mixture of a solute and a solvent. A solution can be saturated solution, unsaturated solution, or supersaturated solutions. So all solutions can be classified into these three categories: saturated solution, unsaturated solution, and supersaturated solution. What's the difference between these three? What's the difference between a saturated solution and an unsaturated solution? Saturation is not anything new to you. You probably would have come across this word before. What is meant by saturation? Let's take a simple example, okay? Let's say you're hungry. You want to eat. Once you start eating, you know you have eaten only half stomach. You're still hungry, right? You still have room for some more food in your tummy. That is called unsaturation, okay? Same thing with a solution. In a solution, when you add solute to the solvent and you start dissolving it, if you're not adding enough solute to the solvent, We call such a solution as unsaturated solution. Unsaturated solutions can take more solute. So let's say you have a big glass of water, right? And you added only 1 spoon of sugar and you stir it, and this sugar has dissolved. It is depending on the amount of water you have taken, you would be able to dissolve more sugar into it, right? Such a solution is called unsaturated solution. That means its tummy is not full. It still has room, it can take more. Okay, it can eat up some more solute. Such a solution is called unsaturated solution. A saturated solution is when your tummy is full. You have eaten enough. So here it has enough solute. It has taken enough solute. You've added sufficient amount of sugar to the glass of water that you have taken. Now, how do I know whether it is saturated or not? When you add sugar and you stir it, it will not dissolve anymore. And you will see that the sugar is actually sitting at the bottom. Such a solution is called saturated solution. That means its tummy is full, it cannot take anymore. Okay, now you take the same beaker with extra sugar in there and put it on the stove, turn it on and start stirring it. You will notice that the sugar starts to dissolve. As you start heating up the water, the sugar starts to dissolve. Now you're resorting to other means to dissolve more solute in there than it can actually take. Such a solution is called supersaturated solution. So this has more solute than what it can take. Okay, this is called a supersaturated solution. Whenever your parents, when your mom is making sweets, right, like laddu or whatever sweet she's making, you can see that she makes what is called syrup. She makes sugar syrup. And if you notice, just go ask your mom out of curiosity, go talk to your mom and see how she makes such syrup. She'll take 1/4 cup of water and she will add 1 full cup of sugar. Okay, so when they make sugar syrup, depending on how concentrated, so I'm using a word here called concentration, right? So we talk about concentration of solution. Now, when you go and talk to your mom about how she, depending on the sweet that they want to make, right? For some, they need high concentrated syrup, while for some, they need low concentration. Some of these parents don't even know anything about chemistry, but still they do all chemistry in the kitchen, right? So what they're doing there is they're changing the concentration of the syrup by changing the amount of solute that they are adding to the solvent, right? So when they want concentrated syrup, they want like really thick concentrated syrup, what are they going to do? They take 1/4 cup of water and they add 1 cup of sugar. Will 1/4 cup of water actually take 1 cup of sugar? No, it cannot. If you just take 1/4 cup of water and you start dissolving 1 cup of sugar, it's not going to dissolve at room temperature. That's going to happen. Because water gets, that 1/4 cup of water is already saturated and all the excess sugar is going to sit at the bottom. So what should they do? They're to put it on the stove and heat it up. When they heat it up, they're able to dissolve excess solute in the solvent, making it a supersaturated solution. That means it's a solution of high concentration. So when the solution cools down, right? when it cools down, what is going to happen? All that extra sugar that you have dissolved in there is going to now come out. It's going to crystallize, right? It's going to crystallize and it's going to come out. Such solutions are called supersaturated solutions. I'm sure you all enjoy rock candy, right? Have you ever thought about how they make rock candy? Have you ever tried making rock candy? It's not that difficult. You can make it at home. All that you need to do is you need to make a supersaturated solution of sugar. You add excess sugar, keep dissolving more and more and more and more. Okay? And keep stirring it. Then what you do is you put a string in there and allow that solution to cool. Over a period of time, if you leave it there for a couple of days, you will notice that all that extra sugar that is in that supersaturated solution, once it cools down, is now going to crystallize and it's going to sit on that string. You're going to get a nice crystal. Now, if you add some food coloring to it, and some essence to it, it's going to look even pretty. So try it out. It's a safe experiment. There is nothing to worry about. You can carry out that experiment at home. Okay, but take your parents' permission though. So you got to be careful. I'm sure you are all old enough to do such an experiment in your kitchen. So all that you're doing there is you're increasing the concentration. Concentration in liters of solution, right? So it is moles per liter. Moles per liter is nothing but the concentration of a solution. All right. So whenever you're talking about concentration, you're talking about the amount of solute. So you're looking at solute over solution. So if you take 1 liter of solution, so if I'm taking 1 liter of solution, the amount of solute that goes into it, that ratio is what is called concentration. Okay, you can vary this concentration by changing the amount of solute that goes into that solution. Okay, the more the solute in the solution, you say that the concentration is high. All right.
I hope these concepts are clear to you. If you found this video useful, do not forget to share it with your friends. And do subscribe to the channel. See you all again in my next video. Bye.